Bristol Community College, Mathematics with Dan Avedikian, Math 131, Elements of College Mathematics, Section 3.3, Problem 7. This is Problem 7 from Section 3.3. It says a small country can grow only 2 crops for export, coffee and cocoa. The country has 500,000 acres of land available for the crops. Long-term contracts require that at least 100,000 acres of land be devoted to coffee and at least 200,000 acres of land to cocoa. Cocoa must be processed locally, and production bottlenecks limit cocoa production to 270,000 acres. Coffee requires 2 workers per acre, with cocoa requiring 5 workers per acre. No more than 1,750,000 people are available for working with these crops. Coffee produces a profit of $250 per acre, and cocoa produces a profit of $550 per acre. How many acres should this country devote to each crop in order to maximize profit? So again, there is a 4-step process to set up the problem, and then 4 more steps to solve it. So the first of the 4 steps to set it up is identify your variables. The variables are the things being made, or in this case grown. It would be coffee and cocoa. So in this particular problem, coffee is mentioned first, so I'm going to label that as x. So to identify my variables, x equals, and we said coffee came first. And the other crop was cocoa. And that is step 1, identify your variables. Step 2 is write out your object function, what you want to maximize. So typically you want to look for information that's about profit, and it usually comes near the end of the problem. And this problem is reasonably straightforward in that sense that it says near the end of the problem, coffee produces a profit of $250 per acre, and cocoa produces a profit of $550 per acre. So what we want to maximize z equals, so coffee was x, and it has a profit of $250 per acre. So I'm going to do 250x plus, and cocoa was y, and cocoa produces a profit of $550 per acre. So my object function that I want to maximize is z equals 250x plus 550y. Step 3 of the 4-step process to set up the problem is write out the constraints. So I'm going to write subject to, and now this problem has quite a few constraints. So the first one, it says the country has 500,000 acres of land available for the crops. So the number of acres of coffee plus the number of acres for cocoa cannot exceed 500,000. So my first constraint is going to be x plus y is less than or equal to 500,000. And that's for the land available. Don't put land. Now, as I go back and read more, it says long-term contracts require that at least 100,000 acres of land be devoted to coffee. At least, so 100,000 or more. 100,000 is the least. So the coffee is x. So x must be greater than or equal to 100,000. The number of acres of coffee must be at least 100,000, so 100,000 or bigger. And next to that it says, and at least 200,000 acres for cocoa. So at least 200,000 acres of land must be devoted to cocoa. Cocoa is y, so I have y must be at least, so it's greater than or equal to 200,000. Now, as I read down to the next sentence, it says cocoa must be produced locally, and production bottlenecks limit cocoa to 270,000 acres. So cocoa is y. The number of acres of cocoa cannot be bigger than 270,000. the number of acres of cocoa must be smaller than or equal to 270,000. Because of the bottlenecks, they cannot make more than 270,000 acres of cocoa. But because of contracts they have, it has to be at least 200,000. So no more than 270,000, but at least 200,000. And now there's one more constraint. It says that you have 1,750,000 people available, and there's so many needed for each acre of coffee and so many needed for each acre of cocoa. So for the workers available, you cannot use more than 1,750,000 workers. I can label that one if I want workers. So now as I read how many workers are used for each acre of each crop, it says coffee requires 2 workers per acre. So coffee is X, and it requires 2 workers per acre. So it's 2X. And then Y, the cocoa requires 5 workers per acre. So 5Y. So the combination of 2X plus 5Y cannot exceed the 1,750,000 workers that are available. So that's step 3, set up the constraints. Step 4 is state that each variable must be greater than or equal to 0. Now, in this particular case, step 4 can be omitted because the X automatically has to be greater than or equal to 0 because it has to be greater than or equal to 100,000. And the Y also has to be greater than or equal to 0 automatically because it must be greater than or equal to 200,000. So in this particular case, if you forgot step 4, it wouldn't matter. Usually it would. For this problem, because of some of the other constraints, it would not. So now it's set up. Step 1, identify the variables is good. Step 2, write out the object function is good. Step 3, set up the constraints is good. Step 4, which is kind of optional, include that each variable is greater than or equal to 0. So now we can start to solve it. So to solve this problem, what we need to do is first graph the feasible region, next label the corner points, then fill out that chart, and then state our solution. So I'm going to go through a few different colors for this. Now, the first constraint, x plus y, is less than or equal to 500,000 for the available land. I want to pretend it's x plus y equals 500,000, and then find 2 points that satisfy that equation. So one easy point is if I zero the x, I'll just have y equals 500,000. And then if I zero the y, then x would equal 500,000. Now, the x greater than or equal to 100,000, imagine a vertical line at x equals 100,000. So x equals 100,000 is just a vertical line, and you want the stuff that's bigger. So it's going to look like that, and that's 100,000 where the vertical line would be. Y is greater than or equal to 200,000. Just imagine a horizontal line at a height of 200,000. And it has to be greater, so you'd want the stuff that's bigger. And then y is less than or equal to 270,000. So I don't know if I have enough colors to do each one in a different color. Let's make this one black. So think of y equals 270,000. It's a horizontal line at a height of 270,000. And you want the stuff that's less than, so you'd shade under that line. And now the last one for the number of workers, 1,750,000 workers. I can go back to red for this one. So this one is going to require a little bit more work. The horizontal and vertical lines are pretty easy, but when you have both variables, I like to make my little x, y chart. And now I want to pretend that the constraint I'm working with is actually an equation, 2x plus 5y equals 1,750,000. Forget the less than for this. So now if I zero out the x, I have the equation 5y equals 1,750,000. So to solve that for y, what I need to do is divide out the 5 in front of the y. And that I will use my calculator for. So I have 1,750,000. I'm going to divide that by 5. So if the x is 0, I find that the y would be 350,000 to make the equation true. And I'll pick up a second point by zeroing the y. And now I would have the equation 2x equals 1,750,000. So I can just cut that in half. I will still do it with the calculator just to make sure I don't make a careless error, because the numbers are pretty big. And I get 875,000. Now I'm ready to start graphing. And because I have numbers that are so big, I have to pick some type of sensible number scale to label my graph. Where my values are going up to 875,000, one at a time, is completely out of the question. Probably 100,000 at a time up to at least 900,000 is a good, sensible choice. And you could go with something else as long as you label it. But I'm going to go with a number scale of 100,000 at a time for my interval. So I started the graph. I didn't label the number scale because I hadn't figured out how big the numbers were going to get corner point of the feasible region. Now, every point on that purple line has an x coordinate of 100,000. So let me draw it out here. 100, I'll put k for 1,000. And every point on the black line has a y coordinate of 300,000. Now I have another corner point for my feasible region where the purple line and green line intersect. So again, every point on the purple line has an x coordinate of 100,000. That's what it means to have a vertical line. All the x coordinates are the same. They're all 100,000 on that purple line. So, and again, I'll put 100k just to fit it on the graph. Now on the green line that forms part of that intersection, every point has a y coordinate of 200,000. Now, I also have an intersection with the green line and one of those two red lines, the red line that goes to 500,000 on either end. So the green line and the red line that goes to 500,000 on either end make a point of intersection. So the red line that goes to 500,000 on either end is the amount of land. The x plus y, and I'm going to put equals 500,000. Now that red line has the equation, the red line that I'm working with for the point of intersection between the red line and the green line, has an equation x plus y equals 500,000. Now the green line, every point on the green line has a y coordinate or height of 200,000. So x plus 200,000 adds up to 500,000. Well, the x must be 300,000. So the point where this red line that goes to 500,000 on either end and the green line where those two intersect has an x coordinate of 300,000, so again I'll put 300k, and a y coordinate of 200,000 because every y coordinate on that line is 200,000. Now I have another intersection with the black line and the red line that goes to 350,000. That's a different red line. Now, the red line that goes to 350,000 came from the number of workers that were available. It is the equation 2x plus 5y equals 1,750,000. That's the equation of the red line involved in my point of intersection between the red line and the black line that I'm working on. Now, every point on the black line has a y coordinate of 300,000. That's what it means to have a horizontal line at a height of 300,000. So I'll put 2x plus 5 times y becomes 5 times 300,000 is going to equal 1,750,000. So now 2x plus here. Should be 1.5 million, but the numbers are so big, I just really need to check it. 5 times 300,000 does sure enough equal 1,500,000. So now, in order to solve for x, I want to bring the 1,500,000 over and subtract it away from the 1,750,000 that's on the right. So I will have 2x equals 250,000. And if I divide out the 2, then x equals 125,000. So the point of intersection between the red line that goes to 350,000 and the black line that I've drawn on my feasible region, the x-coordinate of that point of intersection that I'm talking about is 125,000, which again I'll abbreviate 125k. The y-coordinate is 300,000 because every point on the black line has a y-coordinate of 300,000, which I will abbreviate 300k. Now that leaves me with one final point of intersection where the two red lines intersect. Now what I'll do is see if I can fit it in right up above, because I want to save room to write my chart and to state my solution. So I can trim the graph down a little bit for the part that I'm not using so that I can write it out without writing it too small. So I have one red line that's intersecting coming from the equation x plus y equals 500,000. And the other red line that's forming an intersection comes from the equation 2x plus 5y equals 1,750,000. Now, those are fairly big numbers, but I'm going to use the same process that I always use. I'm going to set it up, multiply one or both equations times something so that one of the variables has the same number in front but with opposite signs. Regardless of how big the numbers get, that's the process you use. I could either cancel the x's with negative 2x and positive 2x, or cancel the y's with negative 5y, positive 5y. Either way, I'm going to get to the same answer in the end. I feel for this one the x's are a little easier to deal with, so I'm going to go with x. Now to go with x, I'm going to take the top equation, x plus y equals 500,000. I'm going to multiply everything in that equation times negative 2, right? Not just 2, negative 2. So first, x times negative 2 is negative 2x. Then y times negative 2 is negative 2y. Then equals 500,000 times negative 2 is going to be negative 1 million. And the bottom equation doesn't need to change. I just copy it exactly as is. It will say 2x plus 5y equals 1,750,000. Now I can combine the two new equations. Well, really, it's one new equation and one of the same old equations over again. If I combine them, I will have negative 2x, positive 2x, which will cancel. Negative 2y, positive 5y, which will be positive 3y. Negative 1 million, positive 1,750,000, which would be positive 750,000. Divide out the 3, and it'll give me y equals 250,000. So the y-coordinate, or height, of the point where the two red lines intersect with each other is 250,000. Now I need to find the x-coordinate. To find the x-coordinate, I can take my y equals 250,000 that I just found, go back to either of the original equations, put in my y of 250,000, and solve for x. The bottom one would certainly work, but it's much tougher. The top one, I can see it in my head. I mean, if I start with the top equation of x plus y equals 500,000, and I know now that the y is 500,000, so x plus 250,000 adds up to 500,000. Well, the x has to also be 250,000. So the point at which the two red lines intersect on my feasible region has the coordinates of the point 250,000 for x, 250,000 for y, which again I'll abbreviate 250k, 250k, just because it would be too packed in to write all the zeros. Now that I've done this much, step one was graph the feasible region, which I graphed. It's a pretty complicated feasible region. Step two is label the corner points, which was a good amount of work, again, because none of them occurred along the x-axis or y-axis, which just gives you the coordinates automatically. We had to do a certain amount of work for all of them. Now, step three, what I'm going to do is fill out one of those charts. And in the chart, I'm going to plug the coordinates of each corner point into my object function and see what type of outputs I get. So, since I didn't need the x is greater than or equal to 0, y is greater than or equal to 0, that was kind of unnecessary. I'm going to erase that just so I'll have a little bit more room for my chart so I can write it without squeezing everything too much. And since I'm going to be using some very big numbers, I'm going to make a kind of a big chart. So the far left column is for corner points. The middle column is for the object function, which for this particular problem is z equals 250x plus 550y. And the last column, the right column, is for output. Now, usually I have like 4 or 5 corner points. This one has 1, 2, 3, 4, 5. Oh, I guess it's still 5. It's not that bad. So I'm going to need 5 rows. So 5 corner points, a chart with 5 rows. You don't have to list the corner points in any special order. I'll just go right around. So one corner point is 100,000, 300,000. And this time I will write out all the zeros, 100,000, 300,000. That's one of my corner points. And I don't want to put in too many commas. It would make it too confusing. Because I use one comma automatically to separate the x and y coordinates of the point. So I'll just put the zeros with no commas. The next corner point coming around is 125,000 for x and 300,000 for y. 125,000 x, 300,000 y. And then I have another corner point at 250,000 for x and 250,000 for y. And then I have another corner point at 300,000 for x, 200,000 for y. And finally, one last corner point, 100,000 for x and 200,000 for y. And now I'm ready to start plugging those x and y values that I just listed of my corner points into the object function. And I have a feeling that I'm going to need my calculator. So the first corner point has an x coordinate of 100,000. So the 250x of my object function will be 250 times 100,000. And plus the 550y becomes 550 times 300,000. So let me do the math for that. So 250 times 100,000, I should have a 25 with 6 zeros, which would be 25 million. That I can do. Plus 550 times 300,000. So it should be a 165 with 6 zeros. Let me check it though. So 550 times 300,000 is a 165 with 6 zeros. So 165 million. So now 25 million plus 165 million is 190 million. So the combination of growing 100,000 acres of coffee and 300,000 acres of cocoa would produce a profit of $190 million. That's what that result means. So now the next corner point that I'm going to evaluate has an x-coordinate of 125,000 and a y-coordinate of 300,000. So as I put that into my object function, the 250x becomes 250 times 125,000, and the 550y becomes 550 times 300,000. Well, the 550 times 300,000 I actually did on the line above, so I'll just remember, without actually doing the math, that it's 165 million. That's easy enough. Now, the 250 times 125,000, let me just do that on the calculator. 250 times 125,000 is 31,250,000. So now I need to add 31,250,000 plus 165 million. That would be 196,256,000. So a little more profit on my next corner point. I'm seeing a profit of 196,250,000 by growing 125,000 acres of coffee and 300,000 acres of cocoa. Now, I'm in the middle row of my chart, 250,000 for coffee, 250,000 for cocoa. Let's see how much profit that will result in. So the 250 times x becomes 250 times 250,000. And the 550y becomes 550 times 250,000. So 250 times 250,000, I think is 625 million. Let me try that. 250 times 250,000 is, I don't know, it's 62,500,000. I missed a spot. So 62,500,000. So it should be 625 with 6 zeros. 1, 2, well, let me try that again. I may have made a mistake with the calculator. 250 times 250,000. So 1, 2, 3 more zeros. 62,500,000. Okay. So now 550 times 250,000. So 550 times 250,000 is 137,500,000. 137,500,000. So I'm going to add 62,500,000 plus 137,500,000 should be a lot, almost 200 million. So let me do that on the calculator. Is 200 million, okay. Kind of thought that's what it was, but wasn't positive. So I have a profit of 200 million by growing 250,000 acres of each type of crop. 250,000 for coffee, 250,000 for cocoa. 2 more corner points left to try. 300,000 for coffee, 200,000 for cocoa. Let's see how much profit we get from that. So 250 times x becomes 250 times 300,000. And then 550 times y becomes 550 times 200,000. So 250 times 300,000 should be 75 million. Let's try it. So 250 times 300,000 is 75 million. And then 550 times 200,000 is 110 million. So 75 million plus 110 million is 185 million. So not quite as much profit as the previous corner point. A lot, but 200 million still seems to be the best. So far, one last corner point to try. 250 times x becomes 250 times 100,000. And then 550 times y becomes 550 times 200,000. So the 550 times 200,000 I just did in the previous line. It's 110 million, so I'll just reuse that work. And then the 250 times 100,000 I did before in the top line. It was 25 million, so I'll reuse that work. And now if I had 25 million plus 110 million, it'll be 135 million. So now finally step 3 of filling out the chart is complete. Big, huge numbers, not necessarily more difficult, certainly more tedious than most of the other charts we've had to fill out for this type of homework. Now I want to state my solution. I'm looking for the maximum profit. My choices are 190 million, 196 million, 250,000, 200 million, 185 million, or 135 million. They're all a lot of money, but the most is a 200 million. So for the state your solution, I am going to put maximum profit of $200 million by growing 250,000. Let me just make sure I've got the right corner point right. The one that was both 250,000. 250,000 acres of coffee and 250,000 acres of cocoa. So this type of solution you could eventually get by trial and error. And after many different growing seasons, you would eventually figure out that the most profit you're going to be able to make is 200 million with that combination of 250,000 acres of each crop. But every season you miss it, you're losing money. By using this system, which was kind of tedious, I mean, this takes quite a while, but it's not a whole growing season, you know on the first try what the maximum is going to be. There is no waste. You get the most money on your first attempt, which is worth knowing this type of method.